All right, so basically what this means is we know the derivative. We've talked about the derivative of this, right? We've talked about the derivative of this. And what we're going to talk about in these last set of notes are what are the derivatives of something like this, right? Or what if it's not e? What if it's like 9 to the 3x or something like that, taking the derivatives like that. There's two ways to do this. One is kind of the longer way, logarithmic differentiation. And actually, these problems aren't going to be that long today. And then the second way is like a shortcut formula. So I'll show you both ways. But first, before we do that, we have to just remember how to convert between exponential and logarithms. So I think if you write this top part down in the box, I can kind of re-explain what this means. I know we've worked with it before, seen it before, but it's probably been a while since we've done anything like this. Okay. No, everyone has like their own way of remembering this type of stuff, but if you have an exponential function and you want to change it to a logarithm, basically the way that I always used to remember it was I would take my two big numbers and pull that on the same side as the logarithm. So that's why that became log base b of y equals, and then you'd always set it equal to whatever your exponent is. Or a way that I would remember this, like let's say you have a logarithm and you want to go back to an exponential, I would always just say, I would picture it like a wheel. Like I would take my base, raise it to what I'm setting it equal to, and set it equal to my y. So that's how you get b to the x equals y. That's how you get from here to here. Let's practice just a couple of those because it's kind of important to know how to do that really quick before we start. So let's change the first one to a logarithm and let's change the second one to an exponential. I'll write the answers up here in about 30 seconds or so you can check. All right, so this one would have been log base 3 of 243 equals x, right? Because we take our two numbers, put it to the logarithm. This one would have been 4 to the third equals x. Just going like that. All right. Okay, let's use that on these next couple problems. So the first method we'll do is logarithmic differentiation, and then slide after this, I'll give you a formula. So we want to find the derivative of y equals 2 to the negative x. Okay. In order to use logarithmic differentiation, you needed to get it. I mean, we'll talk about this more on this second one, but basically you want to get it where you can use natural logs. So on the second one, we're basically going to turn this into an exponential function. This one is already in an exponential function. So logarithmic differentiation says I take the log of both sides, or natural log of both sides, like this. Okay, so remember we would take the natural log of both sides, we would expand it, we would find the derivative, and we would find like dy dx. So this side I can't really expand. This side I can bring that negative x out front. Because remember, we could take exponents, move them out front of logarithms. All right, and at this point, we can start differentiating. So derivative of natural log of y would just be 1 over y, but since it's a y, we're going to write dy dx after it. It's implicit differentiation. Equals, so ln of 2 is just a constant, so that just drops down. But I want to take the derivative of negative x is just -1, so I'm going to write negative ln of 2. All right, and then just remember at the very end, we would want to bring our y over to the other side and then substitute it back in, right? Because we want to solve for dy dx. So I'm going to write dy dx is equal to negative natural log of 2. And again, I want to multiply by my y, which I get from up here, because I want everything in the same. I'm going to plug that back in. So this is going to be dy dx is equal to negative natural log of 2 times 2 to the negative x. Right, this just came from right there. And then last step, let's take that negative exponent. Should rewrite this so it's not so sloppy. Take that negative exponent and put it in the denominator. So this will be natural log of 2 to the x. All right. Let's try this second one, and then we'll be through with kind of like this first method. If we're going to take the natural log of both sides, we have to turn this into an exponential function. So I'm going to take my 10, raise it to my y, and get back to my 2x. So I'm going to say 10 to the y equals 2x. And then I can take the natural log of both sides. So this would be ln 10 to the y equals ln 2x. All right, before we take the derivative, let's expand everything out. So this would be y ln 10 equals ln 2x. Okay, derivative of both sides. This is a constant, so that just drops down. But derivative of y is just 1 dy dx. So I'm just going to write dy dx ln 10 is equal to ln. Actually, I want to take the derivative of this side. Derivative of natural log of u is u prime over u, right? So this would be 2 over 2x. Right, consider this your u. So it'd be u prime over u. Last step, so we're solving for dy dx, so let's just divide out that ln 10. So dy dx is equal to 2 over 2x ln 10. All right. If you did a bunch of these problems, you would start to see a pattern in your answers. All right, a lot of the answers would start to look the same. What that leads to is these are kind of the two shortcut equations that we can do to avoid logarithmic differentiation. You can do either way, but this is a shorter method. So if you jot this down, I'll do a couple examples and then these go pretty quick. So this is when you're dealing with exponentials. This is when you're dealing with logarithms. All right, this will be on the next slide too, but yeah, Zach. Yep, yep. First one's exponential. And there it is, right? U prime over, like if you just compare this answer to what we got right here when we did logarithmic differentiation, it's the same thing. Okay, and actually same thing on the first one. So let's do a couple shortcut method, and then we'll be done with our notes. So let's try taking the derivative of y equals 5 to the negative 4x. All right, when you do these, it's always good to just label, like we're obviously going to use this one, right? It's an exponential function, so we're going to use that shortcut. So it's always good to label what your a and your u is. So this would be my a, this would be my u. Okay. So when I use this formula, I'm going to say y prime is equal to, I'm going to say natural log of a, so natural log of 5, times a to the u, so times 5 to the negative 4x, times u prime, so times negative 4. Okay, and then after that, you're just simplifying. So this would be, I'm going to write negative 4 ln 5 in the numerator. I'm going to write 5 to the positive 4x in the denominator. Okay, so quick way of doing it. All right, let's try the second one, and then the third one's a little bit more work. This one, the second one usually goes pretty quick, these types of problems. Let's label, this is our A, because we're using this formula now, right? We're using the log formula, and this would be my U. So then I would say y prime is equal to, this is going to be u prime in the numerator, so just 5, right? Derivative of 5x is just 5, over natural log of 4 times u is 5x plus 1. And there's nothing really more you can do with that. So this would actually end up being our final answer. Right. Okay, let's do one more. It's a little bit more work on this third one. Let's practice this a little bit. Do log base 3, square root of x over x plus 5. Okay, you have to be careful on these, like when you're dividing and multiplying. You don't want to set like this whole thing equal to your u. I guess, I mean, you could. It would just make a much longer process when you start taking the derivative. What you'd want to do first is just make sure that everything is expanded out as much as you can, and then you can start using this. Okay, so I can rewrite this as log base 3 square root of x minus log base 3 x plus 5, because I'm going to end up using this twice, right? Because there's two spots where we have it. So then we want to make sure it's completely expanded. So this would actually be, this would be the 1/2, but I'm going to pull the 1/2 out front. So this would actually be 1/2 log base 3 of x minus log base 3 of x plus 5. All right, then you can use, now you can use this, because then if we start labeling things, this would be my A, this would be my U, this would be my A, this would be my U. All right, if we start piecing it together, we're gonna have to find common denominators here because we got a couple fractions, we're gonna have a couple fractions. So I'm gonna say y prime is equal to, this is gonna be 1/2 times, so u prime is just gonna be 1. This is gonna be ln 3, and my u is just x, so natural log 3x. Okay, and then minus, this is going to be what, 1 over natural log 3 x plus 5. Okay, I'm just going to rewrite, just to clean up my denominators a little bit, I'm going to rewrite this as 1 over 2x ln 3. And this second part I can just leave ln 3 x plus 5. All right, at that point, we just want to simplify as much as we can. We already have an ln 3, we have an ln 3, so really I just need to multiply this one top and bottom by 2x, and I need to multiply this one top and bottom by x plus 5. Okay, so then we're getting close to the final answer here. So y prime would be x plus 5 minus 2x over 2x, x plus 5, ln 3. And then, so your final answer would be negative x plus 5 over 2x, x plus 5, ln 3. Okay. Jack, yeah. You sure? Okay. All right. Anyone else? All right. This is it. So really what's going to be on your quiz is, your take-home quiz is the stuff we did today and then a little bit of the stuff we did last class period. What I have on this is there's only 6 stations, but I doubled them up. So there's like 6 on this lockers and then 6 on those lockers. So there's 12 of them. So yes, it's spread out a little bit. So if you do that that'll probably take like 15 or 20 minutes. We'll just see how much time we have like before lunch. Maybe we can take another break before lunch, but I'll let you guys go and practice this, and that's it for your notes today. All right. And then those of you at home, same thing. Stations are posted on Canvas. Answers are posted on Canvas. So let's stay on and work through that. And then I think once we get closer to lunch, I'll just let you guys sign off if you're good with everything. Just stay on in case you have questions right now.